Welcome to the Insight Engine. Today's episode is a synthesized technical deep dive into Eyal Estrin's June 19, 2026 Cloud and Cybersecurity newsletter. Internal research indicates a shift toward deep infrastructure integration and zero-trust security designed for non-human identities, moving beyond standalone chat portals. To understand the mechanics of this shift, we need to trace the data through the three pillars of modern deployment: cloud observability, identity-based cybersecurity, and AI token economics. Developer podcasts like AWS Developers and the Enterprise AI Show have highlighted the technical gap between initial prototyping and building a practical enterprise deployment harness. Generating ROI on frontier models requires transitioning from legacy network perimeters to a rewired data layer. Deploying autonomous agents across a distributed network requires absolute observability. If it cannot be visualized, it cannot be secured. AWS recently updated CloudWatch with native OpenTelemetry integration. This allows teams to transmit data via OTLP, unifying custom metrics with AWS vended metrics in real time. By exposing a Prometheus-compatible query API, teams can now extract this standardized data using PromQuell across more than 70 distinct AWS services from a single operational pane. At the data storage layer, Microsoft is attempting to streamline analytics by giving Azure Databricks direct native read access to OneLake without requiring data duplication. They also introduced lake-based branching in public preview. This feature uses a copy-on-write mechanism, letting developers create instant, isolated branches of production data so AI agents can debug edge cases without altering live records. To bridge the visibility gap between these disparate environments, Google Cloud has released Cloud Network Insights. Built in partnership with Broadcom AppNeta, this service uses lightweight software agents to run continuous active synthetic probing. It tracks hop-by-hop metrics like packet loss and jitter at layers 3 and 4, even without live user traffic present. It also integrates a Selenium browser engine for layer 7 digital experience monitoring. This executes JavaScript to measure full page load times, allowing engineers to pinpoint whether a bottleneck stems from application code or the transit network. Without unified cross-platform observability and direct read access, deploying autonomous AI agents creates an operational blind spot. That blind spot is particularly significant because traditional IP-based network perimeters do not scale to manage autonomous, non-human actors. The Cloud Native Computing Foundation outlined an advanced pattern for identity and access management, treating every individual workload as its own trust boundary. This architecture mandates cryptographic identities using SPIFFE and SVID standards, distributing short-lived keys to establish secure TLS connections directly between machines. The Cloud Security Alliance identifies a measurable capability asymmetry between AI-driven attackers and human defenders. Because autonomous agents can probe networks at machine speed, implementing dynamic path deletion boundaries is a mathematical requirement to reduce an organization's vulnerability exposure. We are seeing practical implementations of this model right now, such as Anthropic's release of Workload Identity Federation on the Claude platform. Instead of relying on hard-coded static API keys, this system issues short-lived, scoped OIDC tokens directly from cloud providers to authenticate automated inference engines. Even with cryptographic identities, these systems still rely on human oversight. An ISC2 report surveying global security leaders highlights a specific operational constraint. Artificial intelligence is the top technical capability leaders want to address. Yet while most enterprises officially permit professional development, over half of these leaders cite job demands and scheduling conflicts as the primary barrier to upskilling. Securing the modern enterprise requires a dual approach: deploying zero-trust cryptographic identities for autonomous agents, and allocating operational time for human engineers to audit them. Alongside security, enterprises are managing the economics of AI deployment. Scaling these tools often results in immediate cost overruns. Microsoft recently shifted Copilot Cowork to a variable consumption-based model, where collaborative tasks and agent reasoning steps deduct credits from a shared organizational tenant pool. To maximize token efficiency, Amazon Bedrock's managed knowledge base provides a native agentic retriever that automates recursive reasoning and multi-hop retrieval across disparate datasets. Google Cloud is following a similar path, launching fully managed Model Context Protocol servers that securely connect AI models directly to production databases like AlloyDB to feed real-time context into workflows. An Anthropic study found non-technical domain experts elicited more than double the autonomous AI actions compared to software engineers. Furthermore, novice users abandon difficult troubleshooting loops at 19%, while domain experts fail at just 5%, using their knowledge for precise error correction. This persistence is necessary because frontier models still face intelligence limitations when handling specialized tasks, as highlighted by OpenAI's LifeSciBench research. When tested against complex, multi-step biological research tasks, the top-performing specialized model achieved a pass rate of only 36.1. Anthropic recently disabled commercial access to its Frontier Fable 5 and Mythos 5 models. This suspension followed an emergency U.S. government export control directive. Regulators cited national security concerns regarding a specific jailbreak technique that bypasses model safeguards. Extracting real value from AI requires organizations to manage token consumption costs, prioritize domain expertise over coding skills, and operate within unpredictable regulatory boundaries. The 2026 Enterprise Cloud relies on deep infrastructure alignment to move beyond isolated chatbot capabilities. This foundation uses PromQL-driven observability, enforces security through WAF-based identity federation, and executes actions via consumption-managed workflows. To keep up with these technical shifts, subscribe to the channel for more deep dives into cloud architecture, cybersecurity, and AI integration. Effective enterprise architecture is about leveraging these specific technical integrations to build resilient, verifiable systems. See you in the next build.